Hello, my name is Oliver Kinnane and I'm Assistant Professor at the School of Architecture, Planning and Environmental Policy at University College Dublin in Ireland. And today my presentation and the associated paper are titled, Are nZEBs Nearly nZEB Enough? And I wrote this paper in collaboration with my research colleagues on the nZEB 101 project. That's a project funded by the Sustainable Energy Authority of Ireland, and they are Richard O'Hegarty, Donal Lennon, and Shane Coakley. The nZEB 101 project is investigating a large cohort of nZEB, that's near zero energy buildings in Ireland, 101 buildings to be precise, and it's evaluating the performance of those buildings in use and while occupied. And then it's also comparing the performance of those buildings in use with the performance to which they were designed for. This paper, however, takes a kind of a step back from the day-to-day workings of the project and kind of asks more fundamental questions, such as, is this near zero energy building, this nZEB standard to which Irish buildings and most European buildings are now designed or required to be designed, is it nearly energy efficient enough, given the impending and ongoing climate crisis? The paper asks, even if we build all the new buildings that we're going to build to this very low energy standard, do we have enough of a remaining carbon budget? That's the so-called amount of carbon that we have left before we hit thresholds for climate change. Do we even have enough of that budget left to build these buildings and then to operate them? And this paper tries to crunch through some of the numbers to investigate that kind of global context scenario. So it's something of a conceptual or thought experiment paper that uses construction projections between now and 2060 to evaluate if we really can build this many buildings and if we're building them to an energy efficient standard that's ample. So I'll start by analysing the background or the context for this investigation. And I guess the primary context is the fact that today we already have considerable number of buildings. We have over 230 billion metres squared of built floor area today. And this requires an awful lot of energy to run, and that energy results in significant emissions of carbon dioxide. So we're talking about 3 trillion gigatons of CO2 equivalent each year, or 3 trillion kilograms of CO2 as I've written it here. And when you take into account the indirect emissions from power generation and heat consumption, we're then talking, in 2019, I think it was 10 trillion kilograms of CO2, numbers from the IEA. And if we continue at this level, we will add over 570 trillion kilograms of CO2 equivalent by 2060 through the operation of the buildings we have built today only. And the worry, or that number becomes quite worrisome when we compare it to the carbon budgets that have been calculated through climate models by researchers who work in that field. And a number of these models project different carbon budgets or different thresholds for different climate change triggerings. But a number of the models agree that to avoid a 1.5 degree increase in temperature, we generally need to ensure that we maintain carbon emissions below 500 gigatons of CO2. So the energy required to run our buildings seems to be greater than the the carbon emissions that will result in the running of our buildings is actually greater than the carbon budget that we have left for even a 50% chance of avoiding a 1.5 degree increase in global temperature. But on top of that, we're going to build considerable amount of buildings between now and 2060. It's estimated that we will double the amount of built floor area that we have today. And just to put that in context, if this is New York City, we will essentially build a New York City every month for the next 40 years. So that's 4 times the amount of New York cities that I show on this one slide. And of course, we're doing that because the population's increasing and those people require places to live and places to work. But also because every time we build, today we're increasing the average floor area of that build. And we're adding more and more floor area. Houses are becoming bigger and leisure spaces are becoming bigger with each cycle. So certainly anything that we build, we need to build to very, very high standards. And today in Ireland, we're building and retrofitting our buildings to nZEB standard. So within this paper, we look at some case study data and we look at the performance of those buildings that are designed to very high energy standards. In this case, there are buildings that are retrofit, small, 40 meter squared collection of 12 homes that have been retrofit to a very high standard. But what we see from the data, and this is expanded on in other of our papers within the conference, but what we see in this data is a wide variation in homes all retrofit to the same standard. And the paper goes further to extrapolate out from these findings and to analyse, even if these buildings perform optimally, how much energy will they consume in the construction and the operation of these buildings until 2060. I ask you to read the paper. Thank you for your time.